Hello friends, this video on differential equation part 1 is brought to you by examfear.com. No more fear from exam. What we will study? We will study introduction, order and degree of differential equation, general and particular solutions for differential equation, formation of differential equation whose general solution, and methods of solving first order and first degree differential equation. So before we even study differential equation, let's understand why should we study differential equation. What will happen to us if we don't study differential equation? The same question which we generally ask in all the videos. The first example of differential equation is when you throw a ball from top to down, there we use differential equation. If you talk about population growth, we use differential equation. If you talk about field of science, we extensively use differential equation. In the field of chemistry, where we talk about reactions, we use differential equations. In Newton's law of cooling, differential equation is the critical part. If we talk about radioactive decay, differential equation is used. If you talk about the circuits in physics, differential equation is used. If you talk about these mixtures, some mixture A is coming from here and you're mixing it and it's coming out. So this kind of stuff, this kind of real life problems where you have some mixture flowing in, some mixture flowing out. So in this case also we use differential equations. So before we understand actually what is the use of differential equation in all the scenarios, let's understand the definition of differential equation. The differential equation says that there is nothing but an equation, please note, which defines a relationship between function and one or more derivative of the function. That means I am trying to build a relation between a function. Let's assume this yx be a function or let fx be a function, right? And derivative of the function will be f dash x or f double dash x, right? By what is f dash x? D by dx of fx. What is f double dash x? D by dx of f. Sorry, d2 by dx2 by of x, right? Or you can have f triple dash x. So this is nothing but a relationship between this guy, that is a function, and derivative of the function, right? So these guys are my derivative of the function. That means any relationship between this bucket and this bucket will be my differential equation. For example, if I say that I have d by dx of fx, this guy equal to k into fx, right, plus some constant. This is one differential equation. Why? Because this is the relationship between derivative of fx and some constant. It may be 0 also. Or let's suppose if you have d, your second derivative of this guy, again you have this relationship with the function itself plus some constant. This is also one example of differential equation. Please note, differential equation is nothing but an equation where you have a relationship between function and derivatives of the function. So you have derivatives of the function, function, derivative of the function. In this case it was first order derivative. In this case we had second order derivative. So the definition is pretty simple. An equation where we have a relationship between the function and derivative of the function is called differential equation. Now let's understand all the things which we have studied now, the application of differential equation. So if we talk about the ball falling actually, so if you see the ball is falling, in this case we know that by physics we know that the speed with which the ball is falling will be nothing but, in fact the relation is nothing but dh by dt is some constant, that is g. G is the acceleration due to gravity into t plus 1. This is the equation we got from physics actually for this. When the ball falls, this is the equation we get. If you have this ball falls, and for this the equation is this. If you see this guy, sorry, g into h, this is h, yeah, g into h. So if you see this guy, my h is a function, right? You can see here I am using derivative of h, and here I am using the h only. So I have a relation between the h and derivative of h. So this guy is a differential equation. If you talk about population growth, So in this case, population growth, if you talk about the change of population with respect to time, is nothing but some k into p. This is how the population growth is. Because if you have more population, for example, India, you have more population, it is growing faster. Country which has less population, it grows slower. So that's how it works. So the rate of change of population is also directly proportional to the current population. So this is the equation of the population growth. And here also, if you see, we are talking about this function p and derivative of p. There's a relationship between p and derivative of p. So this is also one example of application of differential equation. In field of science, we use derivative differential equation a lot. For example, in chemistry, if you're talking about reactions, then here also dr by dt is most of the time directly proportional to the rate. The rate of reaction is directly proportional to the reaction. In Newton's law of cooling, we extensively use this guy. How? Because Newton's law of cooling says that rate of change of temperature, the capital T is temperature with respect to time, the small t is time, is nothing but minus k T minus T enviro. T environment temperature. T is the current temperature. So if you see, this guy's T enviro is constant. So if you see, what happens here is, this guy is nothing but this guy and this guy. If you compare, so I'm having T here, I'm having dt by T here, correct? So temperature and rate of change of temperature. So here also, if you see, T and derivative of T, and both are in a relation. So this is also example of differential equation. If you talk about the atomic decay, the decay which you have, so here also, if you see, let's suppose d is decay, then d by dt is here also directly proportional to the d. So rate of decay is also directly proportional to the decay. In case of the circuits which we use in physics, you have this L inductor. For inductor, the E which you have will be L di by dt. For this particular inductor circuit, actually, if I write the equation, my equation will be E is equal to, this will be called L di by dt and plus Ri. Correct. So here also, if you see, for I have this variable here, and this is nothing but derivative of I. So I have one equation where I have I and derivative of I both. So this is also one example of study of differential equation. So the concept is pretty clear now. Any equation which has any function and derivative of the function also, right, with respect to any variable x here actually. So if you have a relationship between these two in one function, then that equation is a differential equation. Or instead of df by dx, I can take second derivative also. So any derivative, first order, second order, you take the function and the derivative of the function, you have a relation, that guy is differential equation. And the practical application for the such kind of equation is in the field of science, mostly in the field of science only, population growth and stuff like that. Let's recapitulate some notations which we'll be using in this chapter. So if I have dy by dx something, right? So where I have to find derivative of y with respect to x, I'll say this guy is nothing but y dash. d2y by dx2, I'll write this guy as y double dash. Similarly, d cube y by dx cube, I'll write this guy as y double dash. But for nth differentiation, I won't write y n type. I can't write like this. For this, I'll use dny by dx. So this is the notation that I'll be using with dy by dx. I'll use y dash. d2y by dx2, I'll use y double dash. d cube y by dx cube, I'll use y triple dash. For any other order of derivative more than 3, I'll use dny by dx to the power n. Correct? Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.